uh, work in the Hbase. So yesterday we had some introduction part for the Hbase. So we'll be using the same terminal in the Cloudera, and then we will be working on how to write the commands, what are the various commands which are there in the Hbase. Okay. So this is your terminal. I have just opened a terminal like this from here, and after opening this terminal in Cloudera, what we have to do is to open the Hbase. See, like when we had to go to the terminal of hi, we were simply writing hi. When we had to go for the peg, we were simply writing peg. And for the Hbase, we have to write Hbase shell, right? So it will take us to the Hbase shell so that we can write the commands, we can create the database in the Hbase, right? So it is giving you the information like uh, what all is available, right? And what is the version that we are working with, right? So now we are in the Hbase shell. So you can see over here. So now let us start creation. So the first thing that we have to do, like because your Hbase, it is a kind of database management system. So what we have to do, we are going to create the tables, and see these tables. They are going to be created in the HDFS only. So what do? We start creating a table like create. So you see the syntax, it varies like in the RDBMS and all we had seen that we are writing, create table. We were using the keyword table. So we don't have to write that keyword table over here. We simply have to write create name of the table. Let us say the name of the table is EMP, right? And after that, simply we are not going to specify any data types, and we are going to simply write the names of the attributes, or you can say that we want to have or the fields that we want to have in this particular table. So let us say we want to write name, then we want to have ID, right? Then we want to have salary of the employee, or we can also have the designation, right? So I'm just writing these designation and just press enter and the table will be created. Are you able to see the screen? Nikunj? Nikunj Chauhan,
Yes, ma'am.
are you able to see the screen?
Yes, ma'am.
Show. The table already exists for the name. So keeper is not working. In the Hbase, zookeeper is responsible for providing all the information, right? What all is existing. See, in this your zoo, in the your Hbase architecture, what we have is we have three main. It is based on the master-slave architecture. So, what is there in this particular architecture? Let me start it again, maybe because it was opened in the morning only. So it's zookeeper has stopped working. Let me see. Right. Just give me a minute. What is it? Cloudera is live. So here we can see what we have in the Cloudera. We have manager node and we have a worker node one. So we have just one cluster. We are working on a single node. We are not working on a cluster of multiple nodes. Uh, you can read it over here. This is just a single node, right? 1 minute. Single. Maybe it's zookeeper is the see in this particular in this architecture of Hbase, we can see we can learn from here that it is asking can't get master address from the zookeeper because it is given that z node data is equal to null. So that your zookeeper is in the Hbase architecture. Zookeeper is mainly responsible for providing all the information about all the nodes which are active or all the nodes which are alive, right? If there is a node that is gone that is failed, so all this information is provided to the master by the zookeeper only. And here they are not, master is not able to get any information from the zookeeper, therefore it is not able to process our request. At present we are a client and we are communicating with the master node and the master in the master slave architecture, and the master is trying to get information from the, so master has seen that what we want to see, we want to see the list of tables, but that information we can get from the zookeeper who is in direct touch with the regional servers. But since zookeeper is not responding, master is not able to process our request. So let us see the architecture first. So I will have to restart it and it's going to take time. Uh, yeah. So basically, in the Hbase architecture, there are three major components. One is Hbase master, who is responsible for maintaining all the information. Like client, as a client, we interact with the Hbase master only. Hbase master is basically responsible for helping us in creation, deletion, updation of all the tables. So it is also playing the role of the administrator and keeps track of everything, whatever is there in the databases. So then we have the H regional server. So basically in this particular architecture of HBase, you see, so what we have is in the, since HBase is built on top of the HDFS, so the input data that we provide, right, whatever data is there that we are trying to create, so all the data is converted into the, you can see the data is in the form of rows as we have seen, like we have columns, column families, each table consists of column families and column families consist of columns and columns. We have the values in the form of key values. right? So it because it is using the hash table, so we have it is all the data is stored in the form of key value systems. So now what we have is, since in the architecture of Hbase, we have three components. One is Hmaster, which is basically the Hbase master. Then we have the regional servers. Regional servers are basically nothing but the nodes which are responsible for processing our data. Like we have the data nodes in the HDFS. So corresponding to the data nodes, we have the regional servers in the HBase. So you can say these regional servers, they are working on top of the data nodes only in the HDFS. So what are these regional servers? Basically, whatever data we have, all this data, if you can recall, in the Hadoop, all the data is processed row wise. So the complete data set that we have, this particular data is divided into regions. So each region consists of a set of rows, and this set of rows varies from you can say according to the row key. Let us say if we are using the integer value for the row key, then from row key 1 to row key, let us say 100, this is one. This is stored. This is one region. Then Roki 101 to Roki 200, this is region 2. So similarly, we can have multiple regions from the same data. So each, you can say the regional server, it stores all these regions, right? So whenever we have to, when we are accessing the data, the master nodes is having all the information on what regions are stored on which particular regional server. So it communicates directly with, so one regional server can store multiple regions. I think more than thousands. You can say thousands of regions can be stored per regional server, because regional servers is basically one node only, right? So in that case, your Hmaster communicates with the your regional server, and the regional server then process that particular request, and sends the result to the Hbase master. Hbase master in turn gives the output to the client. So in between, what we have, the zookeeper. Zookeeper is basically meant for you can say keeping a track of all the regional servers, which are the active servers, which are the failures, and which, so it is responsible for maintaining all the information, so that the master, if there is a failure, in that case, Hmaster is also having information, because it is a distributed database systems. So the replica of the data is available on some other regional server. So if the Hmaster receives the information from the zookeeper, if the node from where the data or the regional server from where the data has to be fetched, if it is active, then the query will be passed over there. Otherwise, this will be redirected to the another regional server, which is having a replica of the same region. So this is how you can say this particular architecture works. So here you can see how the regions are being assigned in the Hbase. So the regions are assigned. So we have the complete key. So you can see we have the start and the end key. Then we have region 1, then another start key to the end key. And this is, and here you can see one region, the size of one region is around 1 GB. So here also, like there is always a limit to the size of the region that can be created, and the amount of and the number of regions that can be stored at one regional server. So this is how you can say the regions are assigned to the region servers. Then tables are horizontally, and for creating the regions, your tables are horizontally partitioned into key ranges, which are called as the regions, as I have already explained. So when we are looking for some data, we are using the get command. You will see over there. So using the get command, we want to receive in Hbase, for reading the data, we use the get command, and for writing the data, we use the put command. And if we want to just see that data in the table, we use the scan command. Right? So then also you can say we have the provisions, and we are working with the database here, that you can enable or disable a table. If you disable a table, then in that case, nobody will be able to see the contents of that particular table. So here you see this is the architecture or the working of the Hbase master. So the Hbase master, as I have told you, it monitors the region servers. So if it keeps track of the all the region servers and assigns the even regions to the region servers. So that means because it is responsible for the creation of the data. So whatever we are trying to put into the tables, so that particular data will be allocated to the particular regional server depending upon the requirement, whether it is going to go for the localization that the data has to be stored nearby, or for the sake of load balancing that one regional server is already overloaded, then the more regions should not be allocated to that particular server. So all these tasks are being handled by the edge master. So the complete allocation is being done by the edge master, and after getting the, if there is some regional server which is failed, so this information is provided to the Hbase master with the, via zookeeper. So accordingly, the Hbase master will be allocating the read-write request to the respective regional servers. So whether the data has to be created or the data has to be deleted or it has to be updated, all these tasks for everything. When I was writing the query, I was communicating with the H master, that is HBase master, and then the HBase master was communicating with the regional server. Since it is the distributed database, so your zookeeper is basically it is the distribution coordination service which is provided, because we in a cluster the data is distributed, but the complete data has been divided into regional servers. It may be depending upon the number of keys. So you may need to access the data for as per your application requirement. You may need to access the data from the various multiple regional servers also. So your heartbeat is basically a mechanism which indicates whether the regional server is active or passive, or it has failed. So it is basically the automatic mechanism, like you can say, of the zookeeper, which helps in keeping track of whether the node is live or not. So this mechanism is basically called as the heartbeat. So as we have already discussed, like each column family, if we see the and see, we have seen what is happening at the back end, and if we see the physical model, your column family is stored in a separate file which is called as the H tables. So the keys and the version numbers are replicated with each column family as shown over here. We have the row keys, then we have the timestamps, and then we have the column family contents. And for every column family, we are specifying, see, contents is the name of the column, and after that we are specifying the name of that content is the name of the column family, and then we are writing HTML, which is the name of the column, and then we are writing the contents over there. So similarly, we have the two tables are showing, one is column family contents and another is the data. So you can see anchor is the name of column family, cnnsi.com is the name of the column. Similarly, in the second row, we see table type 1, 2, anchor is the name of the column family, colon my.log.ca, this is the name of the column. And when the data is being stored, it is compaction is being performed. So during the compaction, you can say the data is converted into small files so that it can be dumped into the actual persistent storage. Before writing the complete data into the persistent storage, the data is being stored in the MAM store, and the empty cells are not stored in the persistent storage. So this is what is being shown over here. We have already seen in the architecture how the data is being distributed into the multiple regions in the regional server. Right. So here you can see that physical structure that is there, how the data is being organized. So what we have in one region, now we are talking about in the one region, what we have the MAM store, we have the Hbase log, which appends only wall on HDFS, like sequence file, one per regional server. Then we have the H files on the HDFS. So basically the region is, so this is complete one region, which is the unit of distribution and the availability. And these regions are split when grown too large. So if the region has grown too large, so all this data is being seen initially before dumping it to the persistent storage. All the data is being stored into the RAM store, and when the data increases beyond a particular limit or whatever is the threshold size, so then it is being dumped into the persistent storage from the MEM store. So the maximum region size is unique parameter. So you can tune it, you can mark it yourself. Then if it is too low, then it will prevent parallel scalability. And if it is too high, then it will make the things very slow. So we should not, so we should, that means when we are creating the splits, so the size of the file should not be very small or it should not be very large. So when if we see the definitions, the region basically a group of cottages as with table rows as we have seen. So there are two types of regions. One is primary and another is secondary. Secondary region is a replicated primary region located on a different regional service. As I've told you, if one node fails, in that case, so what will happen? So this your Hbase is basically a fault tolerant system, and the fault tolerance mechanism because it's you can say it is also following the fault tolerance mechanism that was being provided by the HDFS, because there also we had talked about maintaining the replicas of the data. So here, since that data is stored in the form of regions, so the replica of that particular region is stored at some other location in on some other region server. So that's why we call it the primary region and the secondary region. The replica is called as a secondary region. Then regional server, it serves the data request from one of the regions, and the single region is serviced by only one region server. But a region server may serve multiple regions, right? So we have to remember this particular thing, that a single region is serviced by only. So that means let us say we are requesting some data from one region. So the same request will not be transferred to one more region server. It is like we are like at the same time we are placing an order of the pizza to two different centers. So but we want pizza, one pizza only. We don't have to give the request to the two pizza centers. We have to, so if we want one pizza only, then that means we have to place order at one location only. So similarly over here, so but one pizza center is serving the request of the multiple clients. So the same, so you can say the region server is your pizza center, and the region is basically the pizza that is being serviced by that particular regional server. So your column family is a group of semantically related columns which are stored together. And man store, as we have seen, it is the in-memory storage for the region server. So the region server writes files to the HDFS after the man store reaches a configurable maximum value, as I have already told you. So there is a threshold. So using the command hbase.hr region .memstore.flush.size property, you can this particular property value you can change in the hbase.xml configuration file, and you can you can set the threshold value after which it will be you can say all the data will be stored in the HDFS. Then we have the write ahead log. Basically, it is an in-memory log in which operations are recorded before they are stored in the. So you can see it is kind of cached before the MEM store the data from the client. It all the data goes to the wall, that is write ahead log. Then from the wall the data goes to the MEM store, and from the MEM store the data is being written into the HDFS. Then this compaction storm, it basically happens for a very short period of time, that when the operations are stored in the MEM store, they are flushed to disk, HBase consolidates and merges the many smaller files into the large files. This consolidation is called as the compaction, and it is usually very fast because if the number of files, because when the MEM store has to dump all the files into the HDFS, the compaction is being done so that because everything requires bandwidth for any kind of task, because we are working on the nodes. So in order to save the bandwidth, you can say the compaction task is being formed, so that so the compaction also has in speeding up the write operation into the HDFS. So here you see I'm going to tell you the how to set or how to compute the number of regions which can be supported by the regional servers. So that use of regional server mem store largely determines the maximum number of regions of the region server. Now, we can calculate the number of regions which can be supported by the region server. Since each region has one mem store for each column family. So, if your table has 10 column families, then it will have 10 mem stores, and which grows to a configuration size usually between 128 and 256 MB. So administrators specify this size by using this edge region, as we already told you, this edge region dot mamstore dot flush dot size property, which is there in the configuration file of the Hbase. So the region server dedicates some fraction of the total memory to region memstore based on the value of the Hbase file. So whatever configuration we have specified, so whatever size we have specified, that part of the memory will be allocated to the you can say the mem stores. If the usage exceeds this configuration size, as by it may get overloaded and it may stop responding. So the formula to estimate the number of regions for a region server is equal to region server underscore memory size into memstore fraction divided by memstore size into number of column families. So let us take one example. Let we have a region server with 16 GB of RAM. Memstore fraction is equal to 0.4. Then memstore with, let us say the size of the memstore is 128 MB RAM, and there is only one column family. So we multiply or divide these values, and the final value that we get is approximately 51 regions. So this is how we calculate the size of the memstore or the number of regions which will be there, and how much memory will be required for the number of column families that you have. So you can we have already understood about the Hbase architecture. So here you can see we have the client which interacts with the Hmaster, and you can say the client in between there is a zookeeper which is responsible for maintaining all the information. And from here you can have a broad view of how the things are being stored and what is happening behind the scene. So what we have the Hbase regional server. Within the regional server, we have the Hbase region, and within the region, what we have the hlog, right hand log. Then we have a store where we have within the store what we have the mem store, and we have the file that is called as h file. So the h file is basically the data. You can say the complete tabular data is being stored in the form of h files. And within the regional, we have multiple stores which are storing the data. So we have the multiple regions, right? So similarly, we have multiple regional servers, we have multiple regions within our region, and within the region, we have multiple data files. So all this data is stored as a DFS client, and the underlying architecture, and you can say we are working on top of the data nodes, right? So you can see these are the HDFS client that we are working. So the Hbase sends all its requests to the DFS. So Hbase becomes a client for the DFS. So in turn, the DFS is you can see where we have a name node which is storing all the information, and then it communicates with the data node, and in order to serve the request that is being answered that is to be answered to the client. So basically, the main reason behind the creation of this architecture is to overcome the limitations of the Hadoop and provide the other, you can say, other things which are not provided by the Hadoop in order to solve the existing problems. And along with that, we can see we are able, so the things have become more user friendly. So the large coding that we had to do, we had to learn the Java programming, and we had to do so many tasks. So all those things have been overridden, and with the help of Hbase, we will be writing very simple commands which are easy to write and easy to learn, and we will be able to do the same complicated task and do the storage of large amount of data using the Hbase uh, using the Hbase, right? So that's all for today. बच्चे attend your roll call.